This is a review of scientific notation. If we have a number like 4.3 times 10 to the second meters, and we need to write that in what we call decimal notation or conventional notation, we need to not have the times 10 exponent part. So we need to move the decimal to take that into account. The exponent tells us how many times to move the decimal. The exponent is 2, so we have to move it 2 times. Here's what you get after 1 time, and now you have to move it again, even though there's no more digits. Move the decimal. I still to this day write those little loops so I can keep track of where my decimal is. Then fill in with a 0, and then write the number. 430 meters. That is, in fact, 2 significant figures. When the number is in scientific notation, that will tell you the significant figures. 4.3, it's crystal clear that that's 2 significant figures. So, how do you know which way to move the decimal? A positive exponent is a big number. So that means you have to move the decimal in the direction that gives you a big number. It's as simple as that. 4.3 times 10 to the negative 2 meters, that's going to be a small number because it is a negative exponent. Negative exponent means a small number. 4.3, you have to move it. Now you got to move it in the direction that's going to show a small number, so there's 2 times, fill in with the 0. The decimal is wherever the end of the last arrowhead is. 0.043 meters, again, 2 significant figures. And as I said, a negative exponent does mean a small number. It does not mean a negative number. It means a small number. If we wanted it to show a negative number, it would be out in the front of the 4. If we have something like 0.00784 meters, you still have to move the decimal until the rule is until there is 1 non-zero digit to the left of the decimal. So in this direction, we're going from a decimal number to scientific notation. Move the decimal until there is 1 non-zero digit to the left of the decimal. So 7 is your non-zero digit to the left of the decimal. Then write what you have left. The zeros drop away. 7.84 times 10 to the negative 3 meters. The reason it's a negative 3, the reason it's 3 is because you moved it 3 times. If the reason it's negative 3 is because that's a small number, less than 1. If you stop too soon, you would end up with 0.784 times 10 to the negative 2 meters. You would have only moved it 2 times. That is a perfectly legitimate number. You could put that number in your calculator. It's not like it's not a number, but it is not in scientific notation. It doesn't follow the rules. So we have a few rules here for being able to determine whether a number is in scientific notation and how you know whether you did it right or not. And I should just say to begin here that the reason we do this is to express really large or really small numbers. You can express any number this way, but it's useful for very large or very small numbers. So the rules are the base must always be 10. The exponent of the 10 has to be a non-zero integer. So it can't be a 0 if in the exponent, and it has to be an integer. So not like, 10 to the 0.5 or something like that. And as I said, you have to have 1 non-zero digit to the left of the decimal, so 1 through 9, essentially. And that's how you would know whether you've successfully written a number in scientific notation. So let's check a couple and see whether they are in scientific notation or not. So negative 1.40 times 10 to the 5th, absolutely. 10 is the base, 5 is an integer that's not 0. Just means that's a negative number. All of those are scientific notation on the left. The one on the right is not scientific notation because, in this case, there is a 0 to the left of the decimal, not a non-zero digit. So you'd have to move the decimal between the 1 and the 4. 97 times 10 to the negative 4 is not because where is the decimal? Well, it's after the 7. So you've got 2 digits to the left, the 9 and the 7. And then the last one, 7.46 times 11 to the 3rd, well, that base isn't 10. I don't see that mistake very often, though. Just a couple of examples explaining why. 3.06 times 10 to the 2nd. Again, you're going to write the number, move it 2 times because of the 2. You're moving it to the right because that's a positive exponent, so you have to move it in the direction of a bigger number. The other one, again, you have to move it as many times as the exponent is, fill in with zeros as needed. And I just wanted to explain briefly why this works. 3.2 times 10 to the negative 2, Well, that just means 3.2 times 10 to the negative 2, just rewriting that there. And then remember that a negative exponent from algebra just means you could rewrite that as 1 over that. 1 over x is x to the negative 1. That's a rule from algebra. That's just how we write those. So 10 to the negative 2 is just 1 over 10 to the positive 2. Well, that's 100. 3.2 divided by 100 is 0.032. So generally you can do this again by moving the decimal to the left or the right in the direction of whether it's a big number or a small number. Positive exponent means big number, negative exponent means small number. If the actual number is negative, that negative sign belongs way out in front of the multiplier. I hope that's helpful.